Today we're covering an exciting update in the world of virtualization and emulation. QEMU, one of the most widely used open source machine emulators and virtualizers in the technology world, has just released its latest version, QEMU 10.2. This release represents many significant advances in both features and performance that users, developers, and IT professionals are going to want to know about. In this video, we're going to explore the breadth and depth of what's new in QEMU 10.2, why it matters, and how it can make an impact on your virtualization workflows, development environments, and even performance-critical applications. To begin with, it's important to understand what QEMU actually is, because knowing the foundation helps explain why every update matters so much. At its core, QEMU is a generic and open-source machine emulator and it is a critical piece of software used to emulate entire computing systems and software without needing native hardware support. With QEMU, developers can emulate different processor architectures, run operating systems designed for one type of hardware on another platform entirely, and build highly flexible virtual environments that support many use cases from development to testing, from cloud infrastructure to embedded systems. It can function in full system emulation mode, where it mimics an entire machine, or in user mode emulation, where it runs binaries, compiled for one architecture on a completely different host system. QEMU is also instrumental in hosting virtual machines that leverage kernel-based virtualization through modules like KVM, achieving near-native performance while retaining the flexibility of virtualization. These capabilities have made QEMU a cornerstone tool in everything from Linux distros to cloud orchestration engines and embedded development chains. The release of QEMU version 10.2 marks yet another advancement in the evolution of this essential technology. This is a stablepoint release that introduces multiple new features, architectural improvements, extended support, and performance enhancements. One of the standout features of this release is the introduction of live update support through a new mechanism known as the CPR exec migration mode. This new mode is designed to offer a way to update running virtual machines with minimal resource usage and minimal disruption in ongoing operations. Traditionally, applying updates or modifications to virtualization environments could require downtime or at least significant overhead. With live update support, developers and system administrators can work toward maintaining uptime and continuity even during maintenance windows, optimization tasks, or infrastructure upgrades. The CPR exec name itself hints at how this mode operates. It utilizes checkpoint and execute principles that capture the state of a running virtual machine and intelligently manage the migration of that state in a way that preserves key connections and context. Instead of completely tearing down and rebuilding system state, this approach has the potential to reuse existing states and even existing network connections during updates. That means less resource churn, lower performance overhead during updates, and smoother transition experiences overall for systems running QEMU virtual machines. Alongside live update support, version 10.2 delivers performance improvements that impact many facets of virtualization work. One of the major enhancements comes from switching QEMU's main event loop to use EO_URIN, a modern asynchronous I/O interface supported by the Linux kernel. The integration of EOA_URIN into QEMU represents a strategic investment in performance optimization. It can significantly accelerate I/O operations by minimizing system call overhead and by enabling more efficient submission and completion of asynchronous tasks. This change isn't just about raw speed. It helps reduce latency, improves responsiveness for I/O-bound virtual workloads, and provides a more scalable foundation for high-performance virtualization scenarios. For environments running large numbers of virtual machines or handling heavy I/O demands, this can translate into noticeable gains in overall virtualization, performance, and responsiveness. QEMU 10.2 also brings a wealth of improvements in emulation support across multiple processor architectures, showcasing the ongoing commitment to providing broad and robust multi-architecture emulation. For the ARM architecture, support has been added for a new board model called AMD Virtualization Vici. This broadens the set of virtual hardware configurations that developers can work with, especially in contexts where ARM systems are increasingly prevalent. In addition, enhancements have been made to a number of existing ARM board models, including AST2600, AST2700, AST1030, and XLNX ZincMe configurations, along with support for a suite of new CPU features. These features such as feat_SCLR2, feat_TCR2, feat_CSSC, feat_LSC128, feat_ATS1A, feat_RME_GPC2, feat_IE feat_Mech, and feat_GCS are reflective of the ongoing evolution in processor capabilities and the need to ensure that QEMU keeps pace with real-world hardware advancements. Emulating these features accurately is essential for development, testing, and even performance benchmarking across diverse ARM-based platforms. For classic and legacy architectures, QEMU 10.2 adds and refines emulation support as well. On HPPA Hewlett-Packard Precision Architecture, QEMU now offers emulation for the HP 715/64 workstation. This brings historic computing platforms into reach for enthusiasts, researchers, and anyone interested in preserving or analyzing older systems. Alongside this workstation support, emulation of hardware components like the NCR53 C710 SCSI controller and the HP Lossy multi-IO chip has also been added. These improvements expand the breadth of devices that can be accurately emulated under QEMU, making it easier to run and experiment with zany configurations and legacy operating systems that depend on these components. Moving to PowerPC architecture, which has long-standing relevance in enterprise computing and certain embedded sectors, QEMU 10.2 adds support for new CPU and machine types such as PowerMV 11 and PPE42. It also introduces FADOMP support for P-series machines, a feature that can assist administrators with capturing memory dumps for forensic or debug purposes. These additions keep PowerPC emulation in step with modern needs, while preserving compatibility for legacy workloads. The RISC-V architecture, a modern open-source instruction set architecture that's been gaining momentum in both academic and industry circles, also sees continuous refinement in this release. While RISC-V supporting QEMU already exists, the 10.2 release includes numerous emulation fixes and improvements across various RISC-V subs. These quality-of-life upgrades help ensure that developers working on RISC-V targets get more reliable and accurate behavior when emulating RISC-V environments under QEMU, making it a stronger platform for development, testing, and virtualization targeting future computing landscapes. In addition to architecture-specific enhancements, QEMU 10.2 includes general improvements that touch on other processor families such as S390X and Lungar. In the S390X domain, Versio PCI performance improvements via IRQ FD help enhance I/O performance in virtual machines, pushing QEMU forward as a capable platform for mainframe virtualization. Linarch support has been bolstered with the introduction of MSGI NT-ERKIP support in TCG mode, as well as hardware page table walk support in TCG mode, both aimed at advancing emulation accuracy and performance for this increasingly relevant architecture. One of the often overlooked but highly important aspects of virtualization is the ability to emulate peripheral and device components accurately. In QEMU 10.2, support for replay, protected memory block, RPMB, emulation has been added to the eMMC device model. RPMB is a secure storage partition commonly found in modern embedded systems. An accurate emulation of this feature enables developers to test systems that depend on secure storage features in a virtual environment. In addition, shared file system support for FreeBSD hosts via 9PFS expands compatibility and usability for developers using FreeBSD as the host operating system, allowing guest systems to interact with host file systems in efficient and predictable ways. On the topic of emulation, fidelity, and user mode emulation, QEMU 10.2 includes numerous fixes and improvements that enhance overall stability and correctness. User mode emulation, where QEMU emulates just a single process compiled for another architecture, can be a powerful tool for developers who want to compile and run code across architectures without setting up full system emulation. Improvements in this area help ensure that emulated applications behave more accurately, reducing stumbling blocks in development workflows where cross-architecture execution is required across the entire project. The QEMU 10.2 release cycle also includes an updated approach to documentation, improved build pipeline configurations, and adjustments to the development ecosystem that make contributing to QEMU easier and more structured. For example, the minimum supported version of Rust has been updated to 1.83. Rust is increasingly used in parts of the QEMU ecosystem for certain components and tooling, and having a clearly defined minimum version ensures consistency and compatibility when building QEMU from source or integrating Rust-based extensions and plugins into the development workflow. From a security perspective, QEMU 10.2 has also refined its security policy to clarify which machine types fall under the virtualization use case when classifying and addressing potential security bugs. This clarification helps developers and maintainers prioritize issues more effectively and aligns the project's security model with real-world usage patterns, ensuring a more robust approach to identifying and mitigating vulnerabilities. With all these new features, emulation improvements, architectural support, and performance enhancements, QEMU 10.2 stands as a powerful and compelling update in the virtualization ecosystem. For anyone involved in virtualization technologies, whether you're a systems administrator running mixed workloads, a developer building cross-architecture code, an embedded engineer testing hardware-targeted kernels, or a researcher exploring future computing architectures, the new QEMU release offers many benefits worth exploring. To get started with QEMU 10.2 today, you can download the source code directly from the official QEMU website and compile it yourself if you want the most cutting-edge version right now, or you can wait for the updated packages to arrive in your Linux distributions repositories. Once installed, you'll be able to take advantage of live update support, experience enhanced performance thanks to IO_Uring, and explore extended emulation capabilities across a diverse set of architectures such as ARM PowerPC, RISC-V, HPPA, and S39OS. As virtualization continues to play a central role in modern computing, from cloud infrastructure to edge computing, from legacy system preservation to new hardware innovation, tools like QEMU are increasingly essential. Every release, including QEMU 10.2, represents a collective effort by a global community of contributors to advance the state of open source virtualization. This release not only builds on robust foundations, but also adds meaningful new capabilities that will help shape how developers and organizations build, test, and deploy virtual systems going forward. In closing, QEMU 10.2 is a milestone in virtualization software, bringing together performance, compatibility, flexibility, and innovation. Whether you're pushing the boundaries of emulated hardware support or streamlining your development workflow, this release delivers compelling improvements that are well worth exploring. Thank you for watching, and stay tuned for more deep dives into open source tools and technologies that power the future of computing.